Hello and welcome back to another How to Math. Today we'll be learning how to use a unit circle. So the unit circle is actually divided into four different quadrants. So we have the normal numbering system would be quadrant 1, 2, 3, and quadrant 4. But we also use the abbreviation of CAST, so CAST. This is pretty much determining the sign of the trig ratio. So if the terminal arm were in quadrant 1, where it's A, then the trig ratio would always be positive. Now let's just say the terminal arm was in quadrant 2, and the trig ratio was a sine ratio. So if it was with sine, then it would be positive as well, but if it were cosine whatever or tangent whatever, it would have to be a negative value. And same thing goes for the others. So if the terminal arm were in the third quadrant and it was tangent ratio, it would be positive. If it was sine or cosine, it would be negative. And lastly, if it were in the fourth quadrant, if it were a cosine ratio, then it would be positive value. If it were a sine ratio or a tangent ratio, it would have to be a negative value for the trig ratio. Now that we have that out of the way, we can look at some examples. So we have the first example, just determine the exact value of each trig ratio. So we will be using special triangles in order to find exact values. So 4 pi over 3, so sine 4 pi over 3, what does that equal? So we have 0 here, 0 or 2 pi actually, or 2 pi. And this one over here will be pi over 2. This one will be pi here, and this one will be 3 pi over 2. So 4 pi over 3 will be. So we have 4 pi over 3. So we have 3 pi over 3, and then we have 4 pi over 3. So it's an additional pi over 3. So we have pi over 3 here. And this whole thing will be 4 pi over 3. When we use the sine ratio for a special triangle, sine pi over 3, what would that equal? So we have opposite over hypotenuse. That would actually be root 3 over 2. Now we have to pay attention to which quadrant this terminal arm is in. So as we can see, it is in the tangent quadrant, meaning that the sign would actually be negative. If this were in the sine quadrant or the all quadrant, then it would be positive value. Since it is in tangent, it would be a negative root 3 over 2. Now moving on to another example, we have cosine 11 pi over 6. This equals, so 11 pi over 6, where would that be? I could erase this for now. Okay, so 11 pi over 6. So, well, first we have 6 pi over 6, or just pi, and then we have another 5 pi over 6 to go. So 5 pi over 6 would be, so that's 3 pi over 6, and then we have another 2 pi over 6. That'll be around here. This terminal arm, and this little related acute angle would be pi over 6. So now we can use another special triangle. It's the same one, but different angle. So cosine, so cosine pi over 6, adjacent over hypotenuse, that would actually be root 3 over 2. Again, so root 3 over 2. But now since it is cosine ratio and we are in the cosine quadrant, this would remain as a positive value. It would not change the sign because it is in the cosine quadrant. Now we can move on to other examples. So we can use the related acute angles in order to state equivalent expressions of sine 150, cosine 340, and tangent 260. So first we have to determine where the terminal arm is in order to figure out what the value of the value of the trig ratio is, whether it is positive, negative, or whatever. Yeah. So first we have sine 150. Sine 150 will be, so this is 90, and this is an additional 60. What's left is 30. So we have 30 degrees here, and we have 150 degrees here. Terminal arm is in the sine quadrant. It is a sine ratio. Therefore, so sine 30 degrees would be equal to 1 over 2. So we're using we can actually use a special triangle because it is one of these trig ratios, right? It's 60, this would be 2, this would be 1, and this would be root 3. So sine 30 degrees is 1 over 2. Therefore, sine 150 is 1 over 2 as well. Now we can move on to the next example. First, we'd have to draw where the terminal arm would be, in which quadrant, before we can evaluate the value of this trig ratio. So erase one more thing. There we go. Okay, so cosine 340. First, we have to figure out where 340 is. So this is 90, 180, 270, 340. So this is 340, while the remaining will be 20 degrees. So this actually this is not a special triangle, so we could use a calculator to evaluate this. Now, as we see, the terminal arm is in quadrant is in quadrant C, where for cosine, where if it's a cosine ratio, it would be positive. So therefore, we don't have to change the sign of this trig ratio, and we just evaluate. So cosine 340 degrees is equal to 0.9397. We don't change the sign again because it is in the proper quadrant. Now we can move on to the final example of determining equivalent trig ratios using related acute angles. So we have tangent 260, so we have 90, 180, and then we stop just before 270 to make it 260. So this whole thing will be 260. But from here, so 260 minus 180, we're using the related acute angle, right? So 260 minus 180, that will equal 80. So this angle right here, this angle is equal to 80. Sorry, it's a bit hard to read, but that's 80 degrees. So therefore, we actually have to look at the quadrant, right? We do that first. So it's in the tangent quadrant, and it is a tangent ratio. So the value remains positive. Tangent 80 is equal to about 5.6713. 5.6713. Therefore, that is the exact value, or approximate value in this case, of tangent 260, cosine 340, and the exact value of sine 150 using the unit circle. Now we can move on to a word problem, actually. This word problem is in 3 parts. It is asking, given cosine theta, so cosine theta equals negative 5 over 12, and we have where theta is within 0 degrees and 360 degrees. So we have this given to us. A is asking, in which quadrant could the terminal arm of theta lie in? So as we can see, it is a negative trig ratio. That would mean that the terminal arm would have to lie in either the second or third quadrant, because that is the sine or tangent quadrant. So we can state in either quadrant 2 or 3. And then we can move on to B, which is asking determine all possible primary trigonometric ratios for theta. So as we can see, for theta, So that would either be, we can have sine theta equal to, so when we have, let's say, it's over here, so whatever sine theta, that would be equal to the positive, it would be positive value in here. So we have 5, we have 12, and then we have root 119, because 144 minus 25 square root is root 119. So opposite over hypotenuse, that is the sine ratio, root 119 over 12. It remains positive because it is in the second quadrant. So that's one trig ratio, primary trig ratio for theta. Or it could be tangent theta. If it were still in the second quadrant, that would be negative roots 119 over 5. Now let's just say that it were in the third quadrant, actually. Let's say that it was in the third quadrant. It would be about here. So this would be root 119. This would be 12. This would be, yeah, so whatever angle. So we have angle theta, which goes from 0 all the way to the terminal arm. This theta. We can use a related acute angle, beta over here. So tangent theta would equal positive, so it would be tan theta equals root 119 over 5, but sine theta in this case would be equal to negative root 119 over 12. So that is, those are the primary trig ratios. And then moving on to C, this is saying evaluate all possible values of theta to the nearest degree. First we'll clear up the board and we'll do this question. So all possible values of theta, remember theta will always be from the angle 0 all the way to the terminal arm. So if theta were like this, theta were like this, and this is the terminal arm, and this would be the related acute angle beta. So we could use, yeah, well, I mean, so sine theta equal to root 119 over 12, but it's also equal to sine beta, right? If it was in this case. So sine beta equals root 119 over 12 equals root 119 over 12. You can use a calculator to find beta, which is equal to, so inverse sine root 119 over 12, which is equal to about 65.38 degrees. So that is the angle of beta. In order to find theta, we can actually just subtract 180 minus 65.38 in order to find theta. So 180, minus 65.38 is equal to theta. So which equals 180 equals about, so it equals 114.62 degrees. And then we can move on to, let's just say that it was in the third quadrant. So if the terminal arm were in the third quadrant, we'd have theta all the way down here. This is the whole thing is theta, but this little part will be beta after the 180 point. So we have this terminal arm over here. Now we can use tangent beta. So if it was in the third quadrant, tangent beta is equal to root 119 over 5. So tangent beta is equal to root 119 over 5. Therefore, beta in this case would equal root 119 over 5, which is, yeah, so it's 65.38 degrees still. But in this case, we'd actually have to add it to 180 degrees in order to find theta, because theta goes all the way across past 180 plus the beta. So theta could also equal 180 degrees plus 65.38 degrees, which equals about, so we have 180 plus beta, which is equal to about 245.38 degrees. Therefore, the values of theta would be equal to about 115 degrees or 245 degrees. So there we have it. That is unit circle in trigonometry. I hope this helps, and I'll see you guys in the next video.